请到前方做准备。
Good morning, everyone. We're a team from Mingo High School. I'm Yang Qingyu.
And I'm Hong Chenwei. I'm Mingo Ray.
Today, we're excited to present our experiment proposal. In this experiment, we're exploring a fascinating question: how do lightweight objects like lint-free white move in microgravity? While the motion of large objects in space has been well studied, such as spacecraft and debris, the behavior of something as light as lint-free white remains largely unexplored. We want to bridge the gap, shedding the light on how lightweight objects interact with airflow in microgravity. And also, our objectives are to observe their motion under forces and investigate potential application in such environment. We hypothesize that airflow will dominate an object's motion in microgravity. We also assume that the mass and the shape of the object will affect its stability. For instance, a lint-free white may rotate more, where origami paper could exhibit steadier movement. These ideas are rooted in theories, such as Newton's second law and the principle of inertia. Without gravity, an object's motions depend entirely on external forces, such as airflow. Furthermore, due to their lightweight nature and large surface area, air resistance is expected to significantly influence its behavior of these objects.
Right, so the material we got is an origami paper, lint-free white, a straw, a red pen, and a black pen. So now let me show you our design of our experiments. It's very simple. Step 1, we draw 4 crosses on the both origami paper and the lint-free white to represent the XY axis and the 4 quadrants. And step 2 to step 4, we're going to use our straw to blow at the different positions on the paper. The center, the X on the x-axis, and the cross on the first quadrant. So by observing the motion and the deformation of the paper under these conditions, we aim to understand how the airflow affects lightweight materials in the microgravity conditions. So why is the movement on Earth? It's all the same. It will make an oscillations movement first, and then it falls down because of the gravity. But what it will be when it's on the microgravity conditions?
Now, let me guide you through the expected outcomes of our experiment. First, when air is blown directly at the center of a soft lint-free white, we anticipate it will bounce backward while maintaining its shape and moving straight ahead. Conversely, for stiffer materials like origami paper, the bouncing effect will be less pronounced and the motion will remain primarily linear. Second, if air is direct at a point along the 1/4 or 3/4 position of the x or y axis, we expect the object shape to deform around the impact point. The deformation will be more noticeable in softer materials, causing them to flip or rotate in place. Last, when air is blown into the 4 quadrants of papers, we predict the deformation will align with these regions, resulting in a diagonal flip and more complex rotational movements. As for the conclusion and application for this study, we firmly believe that our findings can advance the ability to control motion of lightweight objects in microgravity environments. The data gathered from this experiment might also serve as valuable insight for designing lightweight material or structure that operate stably in space. Most importantly, This simple yet intuitive experience aims to ignite curiosity and inspire a passion for space exploration, offering an accessible way to engage with science and engineering. In conclusion, our experience, Paperfly, not only seeks to answer fundamental questions about motion in microgravity, but also provide an educational inspiration. Thank you for your attention.
谢谢参赛队伍的